This lesson was on three-dimensional figures. We were concerned with finding and modeling the volume of three-dimensional figures. You had a homework assignment related with this on Canvas. Volume is just the measure of the amount of space enclosed or held in by a 3D figure. We were really concerned with primarily two different types of, or two different categories of 3D figures. Prisms and cylinders, which have two parallel congruent bases, and pyramids and cones, which have one base and a vertex. We can see an example of a prism here. Examples of prisms in everyday life is any sort of box that you have. This box here would be an example of a prism. My phone would be an example of a prism because it's a 3D shape which has two faces that are the same size, congruent, and are parallel to each other. Your cones, your cylinders, are your cans of soup, your water bottles. Their tires and wheels are examples of cylinders. They have two parallel bases that are the same size. Your pyramids, you've got examples of pyramids, and your cones, your party hats. They have one base to worry about and a vertex, a sharp other end to them. Your prisms, in general, have the two bases connected by rectangles. The two bases here, this pentagon and this pentagon, are connected to each other by rectangles or squares or some other parallelogram. Pyramids have their bases connect to the vertex using a bunch of triangles. Your prisms and pyramids are named by the shape of their base. It's important that you identify what the base is. Here, the base is a pentagon, so we call it a pentagonal prism. Here, the base of this pyramid was a square, so we call it a square pyramid. Then we've got a cylinder, a cone, and a sphere. Important thing to note, from the center to the edge of this, just as a reminder, that's your radius on your circle. If it has a circular behavior to it, it has a radius somewhere. The cone has a radius. If there's any bit of curving on your shape at all, it has a radius. From the center to the edge is the radius. From here in class we did the word problems primarily. If we got time, we'll come back and do the finding the volume, but it's generally you just need to identify the information and plug things in. The volume of this cone is going to be 1/3 capital B. Capital B from your reference sheet is the area of that base. Capital B is the area of the base. So you had to be concerned about what the base shape was. The base is a circle. We get to replace that capital B with the formula for the area of a circle, with the formula pi r squared times h. Then you get to plug in your radius and your height. You would want to do similar things here for your rectangular prism. This is a rectangular prism. Much more interesting were the word problems. We've got a Tiankeng is a sinkhole with a nearly vertical walls. The Tianping Tiankeng is approximately cylindrical, so it's a cylinder shape. It's shaped like a can, with a diameter of 180 meters and a depth of 420. We want to know what is the volume of water that could fill this Tianking. Well, I take a look at my reference sheet. I find the volume of a cylinder is the capital B base, meaning the area of the base shape, times the height. Let's label it. We've got 420 meters. Here is the height. The distance across this is 180. Meaning our radius is half of that. The radius is 90 meters. This was possibly the most important problem on this worksheet because of the calculations we had to be concerned with. The base of our cylinder is the circles. We need the area of the base. We need the area of the circle. It's pi times the radius squared times the height. From that, we could just plug things in. We knew what the radius was 90. We knew the height was 420. So we did pi times 90 squared times 420. I asked you to do just the multiplication of 90 squared times 420. And people are giving me 3 million. People are giving me 3,402,000 pi. I wanted people to stop here briefly because I wanted you to understand that this is considered an exact answer. This exact answer is something that would be wanted on desired tests. The next thing we wanted to be concerned with was giving a decimal answer here. To get your decimal answer, just actually multiply it by pi. Actually do the multiplication there. We would get 10,687,698.2. I stopped there when we rounded. We got this answer using pi in your calculator. It's important that you use the pi button in the calculator on your tests. If you don't, you could be 5,000 off. If you did 3.14 instead, you could get instead 10,682,280. That's using 3.14. Using 3.14, you would be marked wrong on the test. This would be marked wrong. Use the pi button when you use the calculator. Next, we had a candle in the shape of a pyramid. They didn't say what kind of pyramid, so I drew a square pyramid, but it could have been a triangular pyramid. Do my best to draw a triangular pyramid here. It could have been a pentagonal pyramid. It could have been any kind of pyramid. All we knew in this case was that the volume was 27 cubic centimeters, and its height was 6 centimeters. And we wanted the area of the base. Well, luckily, capital B is the area of the base. So we get to make those substitutions. We get to say that volume, V is 27, is 1/3 of B times 6. And we're just going to find out what B is. We can do that by doing 1/3 of 6 is 2. B equals 27. We'll get B, the area of our base of this candle. should be 13.5. So B is 13.5 centimeters squared, since we're finding an area. On the back of it, we had all these different formulas here for prisms, right regular pyramids, cylinders, cones, and spheres. You had this as a reference during class. But these formulas are not exactly the same ones as on your reference sheet. They're very similar, but you need to know your reference sheet and know how to use it. Last thing we had to worry about was this silo problem. A silo is used for storing grain, and it's shaped like a cylinder with a cone on top. And we can see the cylinder over here on the bottom, and we can see the cone on top. The radius of our cylinder is 8 feet. The height of the cylinder part is 25 feet, and the height of the cone is 6. So adding that onto the diagram, we got 6 feet there, we got 25 feet here, and we've got a radius for both of those of 8 feet. And we're going to break this problem into a couple parts. We're going to find the volume of the cylinder part of the silo, ran to the nearest cubic foot, and we just write down our formula. Volume is the area of the base times the height for a cylinder. Our formula sheet shows something much more complex. The reference sheet is going to give you the same formulas for prisms and cylinders, because all that's changing is that this capital B is replaced by pi r squared because it's a circular base. It has a circular area. We'll do that as well. We'll say our base is circular. It is pi times the radius squared times the height. That looks like pi times 8 squared times 25. We'll run 8 squared times 25 through a calculator. We'll get an exact answer because it's nice to get an exact answer. Our exact answer would be 1600 pi cubic feet. I'm putting in parentheses that this is exact. If we want to round it, we'll just multiply it by the pi button. We get 5,020, rounding it to the nearest cubic foot, 5,027 cubic feet. Similar thing for the cone. We look at the volume for a cone. The cone is 1/3. It's just the base. The base is a circle, the area of the base, times the height. It's the same as your pyramid. Volume is 1/3 base area, area of the base times the height. We make our substitution of 1/3 times pi r squared times h. We'll substitute the appropriate numbers in. It's 1/3 times pi times the radius is still 8, but now the height of the cone, the height of the cone is 6 feet. Again, we'll get an exact answer by doing 1/3 of 8 squared times 6. 8 squared times 6 divided by 3. we get 128 pi cubic feet. And if we multiply that by pi, we get, when rounded, 402 cubic feet. One of these is considered exact, the other is rounded. Now, to get the volume of the entire silo, we can just add our two measurements. 402 plus 5,027. We get 5,429 cubic feet. At least based on our rounded values. I want to say we could add these two measurements. They both have pi. We can add 1,600 pi and 128 pi to get 1,728 pi cubic feet. And we can see if that is really that different from 5,429. Let's see, 1,728 times pi gets us, as a note here, 5,428.6, which rounds to our 5,429. It works out that rounding earlier ends up being the same whether we are keeping our exact answer or not.